Okay, yes, I'm Stuart Wintertier. I'm a secure design analyst at Continuum Security, and Continuum Security are a very talented bunch. I'm not just saying that for lip service, they really are. My wife describes me as a wallflower in real life, but on Twitter I put the world to rights. So you can find me there on Stego Packs afterwards. I'm an InfoSec generalist, so jack of all, master of none. I have tried to put that right, but there you go. For some reason, when I put these slides together, I had a need to tell you that I'd read a book on presentation skills. I really don't think it's helped at all. But I did learn something, and that was that I should tell stories to make this more interesting for you. That really worried me, so I asked my wife what stories I should tell, and my little one said, "Why don't you tell them the story of how you became a genius?" Which I thought was lovely. I'm not looking forward to when his bubbles burst, but you know, it was a lovely thing. So that was your story. I hope you enjoyed it, okay? That was the best effort I could do. I also learned that you won't remember anything from this talk. Apparently, most of you, after 30 minutes, will remember less than 3 things, okay? So all this worry I've put into it, you won't remember it anyway. But in that spirit, I thought, well, I might as well be honest. You won't remember it. If you're in InfoSec, and some of you hopefully are, and you may feel differently to me, that's absolutely fine, but if you're in InfoSec for any length of time, there comes a point in which you feel something's not quite right in the world of InfoSec. The breaches, the bugs, the flaws, the whack-a-mole, the fighting against the tide, the way other people feel about security people, I won't go into that, but there comes a time when you think that something perhaps not quite right, and I've spoken to others that feel the same. And I think that's what drives, or a symptom of that, is what drives our desire to find a silver bullet, that new box that's going to solve all our problems. But sadly, there are no silver bullets, except for bug bounties. At least that's what I thought. See, I'm not immune to these problems of looking for a silver bullet as well. And when bug bounties hit mainstream a couple of years ago, I looked at it and I thought to myself, there is a solution here. You know, we can crowdsource these excellent researchers. They can look at these problems for us. We can pay them before the criminals get there. Perhaps this is the solution. In fact, I was so enamored with it, I decided that I'd hook up with a global travel company, and I would, out of the goodness of my heart and for the benefit of mankind, I would myself do bug hunting for them. It was nothing to do with the prizes they gave for free flights and free hotels if you found bugs. Nothing to do with that at all. The reason I tell you this story is because I don't consider myself very good at bug hunting. I wasn't stringing together brilliant 0 days and all the rest of it. I simply found these problems, and a lot of problems, through reconnaissance. And the problems I was finding were problems related to design. And they were basic errors, basic problems. And really what it told me is that that feeling that I'd had that something was wrong in security was right, and it still stood. And that at the end of the day, bug bounties weren't going to solve this for us. It was a lot deeper than that problem. And this was a very, very savvy company that makes its living online. So it wasn't just them. This is endemic. This is a much larger problem, okay? Then, some time ago, I discovered evil brainstorming. Now, I didn't put that term together, evil brainstorming. It came from Tanya Janka, who you should follow online if you're not already. But it's another way of saying threat modeling, okay? Now, I don't know how many of you are threat modeled, or I don't know, where you're at with it. You might never have heard of it, but just to give you a breakdown of what threat modeling is, it's been broken down into 4 core components, that most famously, okay? And that is, what are we building? What can go wrong? What are we going to do about it? And did we do a good job, okay? The process of what are we building sounds obvious. Well, we're building an app. We're building a web app. What could be more complex than that? Well, actually, it can be more complex than that nowadays. There's so many moving parts. And if you do threat modeling, it can be interesting. You get people together, you get the multidisciplinary teams in together to talk about what you are actually building, and there can be disagreement. People don't actually know what you're building, interestingly. The next phase, what can go wrong, is the evil brainstorming. Okay, so we look at what we're building, and we say to ourselves, where are our weak points? Where are our vulnerabilities? Where's our soft underbelly? Okay? And we look at it from a criminal perspective, from their modus operandus, and we try to look at the ways they could attack us, and we write down the threats that are applicable to our architecture. What are we going to do about it? What are we going to do about those threats? For me personally, it's always been about raising the bar against the attacker. Criminals are lazy and like low-hanging fruit. They're opportunists. Cyber criminals are no different. We must raise the bar against them first and foremost, and you will find if you raise the bar, a lot of them will move on to another target. That's just a fact. They don't want to spend ages and ages. They get frustrated. They move on. There's plenty of other targets out there for them. So for me, what are we going to do about it? It's always been about putting controls in that raise the bar. And fourthly, did we do a good job? So that's pretty self-evident. We look at the we look at the first three, and did we do a good job about that? You know, did we do this well? Okay? To me, this speaks simply of secure design. When we look at other industries, we note that they engineer security into the design phase. But for some reason, and I don't know why, historically with software, we tend to build it and then we deal with security, which means that we end up bolting security on at the end. And that's what really, the light bulb went off for me really with threat modeling, because I realized that we've got to get security into the design phase. We've got to shift left. That's what the movement's called. We've got to shift left. And I don't think we can do that without threat modeling. I think threat modeling is how we do that, is how we start to engineer security into the design phase. And there's been plenty of studies done that say, quite simply, fixing problems after production is far, far more costly than it is to fix things at the design phase, at the beginning of the life cycle. Personally, I think that's intuitively obvious. Okay? I didn't really need a study to tell me that, but I think that's intuitively obvious. And that is what threat modeling is about and secure design is about. It's about finding the problems and fixing them early on. Okay? So why aren't we threat modeling? Well, we've always done it in a certain way, like conference talks with PowerPoint. Not really. It's a little bit more than that. If you discover threat modeling, as I did, and then you start reading about it and you start investigating it, you will find only the manual way of doing it. Okay? And that is slow, hard work. It talks of bringing in multidisciplinary teams from all across the business, okay, to look at the applications you're building and to spend 4 or 5 hours threat modeling each application, right? That's skill intensive. I don't know about you, I have trouble getting 3 people together for 10 minutes for a video conferencing, let alone trying to get six interdisciplinary teams together to threat model for 5 hours on every application. We have a consistency problem in that if I bring one team in to threat model the application, and then I bring another team in to threat model the application, the likelihood is we're going to end up with 2 different models. They're not going to be identical. It's just the way it's going to be. So at the end of the day, and the threat modeling purists will string me up for saying this, it's slow, it's impossible to scale, it isn't systematic, it becomes a bottleneck. Security is already perceived as a bottleneck. Can we really introduce another bottleneck at the beginning of the process and say, now you've got to do that? It's not going to wash. And sadly, threat models do get left behind. When they are done, they do get left behind because people just haven't got the time to continue with them. We're living in a fast-paced environment, a DevOps environment, and manual forms of threat modeling simply don't work. It's a shame, but it's true. It doesn't work. So what can we do about this problem? Well, if you have threat modeled, what you'll tend to find in the manual form is that in the beginning of the process, you'll enumerate a lot of threats. But as time goes on, the enumeration of those threats goes down, and it gets harder and harder and harder to get to those threats. I'm going to unscientifically call the first section the easy stuff and the second section the hard stuff. What I'm proposing is that we automate the easy stuff, so we get the easy stuff fast. Now you can see that's not a 100% accurate threat model, 75% accurate threat model, but it's viable enough for us, okay? And we can do this fast enough to move into a DevOps, a fast-paced DevOps and agile environment, okay? So if you do the manual threat modeling, and let me say, if you're only doing 10 applications a year, ignore all of this and do manual threat modeling, because you're going to get a greater degree of accuracy. But we are making a trade-off here for speed. And the way that I suggest that we do that is we threat model with templates and with patterns, okay? With building blocks. My son, the one that said about me being a genius, is himself a Lego genius. Now, the reason I say that is because he can take so many different bricks, okay, the same bricks, and yet he can make so many different things from those same bricks. And it's actually similar in the software environment as well. If you ask people, are you making something novel, which I sometimes do, they say to me, yes, we're making something really novel. But when you dig down to the architectural components that comprise that, they're always the same. Okay, that's just the way it is. And the security community has recognized this and have come up with technology standards, technology-centric standards that for us that recognize that we often use the same building blocks. Okay, OWASP, Application Security Verification Standard V2, is the prime example, probably the one, if we're familiar with any of them, that's the one we're going to be most familiar with. And I chose this security verification requirement 2.16 randomly because I thought, well, is what I'm about to say, is it true, does it work? So I chose it randomly. Verify that all application data is transmitted over an encrypted channel. What we have here is the section, what are we going to do about it, from the four components of threat modeling. Okay? So they've jumped and they've given us, what are we going to do about it? Okay? So what we should do then is we should take OWASP, ASVs, and then we should dump that on our developers and say, get on with that. No. They're going to be overwhelmed. It's just simply not going to work, unfortunately. So we need to take a more sophisticated approach. So option one, we take something like ASVs, and we fork it, and we create a template based on our standard architecture, and we get rid of some countermeasures, and we bring in some countermeasures that are relevant to us. Okay? The good thing about this is we're now prescriptive during design phase, so we can pass this to developers right at the beginning of the design phase. But the problem with this is that we're prescriptive during the design phase. What I mean by that is that all we're doing is we're passing over to our developers, do this. Okay? They've no idea why they have to do it. We've passed over no body of knowledge. They can make no trade-offs or independent decisions. We've just said, do this. And that's not good enough in today's environment. We need to be spreading security knowledge to our peers. Okay? If we come back to this same security verification requirement, verify that all application data is transmitted over an encrypted channel, interestingly, lying behind that is a threat model. Implicitly is a threat model. For example, we can infer a threat model from this. And in this instance, I would say that threat model would be attackers could gain access to sensitive data in transit. So, verify that all application data is transmitted over an encrypted channel. We now have two parts. If we do that, if we reverse engineer it and come to the threat, we now have two parts of our methodology. What can go wrong, and what are we going to do about it? This is a good place to be. It's not perfect, but it's a good place to be, and we can pass that information over to those that are actually building these services and applications for us. How do we communicate? People have done wonderful things in Excel, Confluence, BDD stories. I'll give you an example in Excel, very simply. You can see I've got the threat, I've got the control, and in the middle I've popped in the vulnerability. And the reason I've popped in the vulnerability is because I believe one of the key benefits from threat modeling is it should be driving our testing. It should be driving our pen testing. Too often we ask for pen testers to come in, we give them an application, we say, pen test that, and off they go. But through threat modeling, we can find those things that they really should be focusing in on and what they should test. That's my opinion. Also, you'll note in risk I've put low, just to give an indication of, is this something that could be left behind? Is it vital? Is it desperate? Anyway, the most important thing is that we communicate it in the language of our peers. No longer can security sit in its own bubble, writing its own documents in its own language, and then expecting everybody else to pick up on it. If our peers are working in issue trackers or their own workflow tools, it's time for us to communicate within their tools, okay? Not our tools, their tools, to get into their flow, so that we truly can become not just DevOps, but Sec DevOps. This is our only way. We need to learn their language. That's just my opinion. We still have a problem with option 1, and that's that we're still in a one-size-fits-all situation. Our template may well be too big for our threat model, and we annoy our developers who've got to get rid of a lot of controls and countermeasures that are of no interest. Or they build something that's slightly different from the norm, and our threat model doesn't really cover it very well. And this is the core of the approach that I'm advocating today, is this next one. What we threat model is individual components of an architecture. And we call that risk patterns. And risk patterns are threats, weaknesses, and countermeasures coalescing together on specific components of an architecture. Okay? So we threat model a web service in isolation. We threat model a web UI in isolation. We threat model a database in isolation. Okay? And we can put it up in a way like this for our developers, so they can simply choose what it is they're building, and then once they select that, they'll see the security requirements we've already put in place for it. But we can go better than this. For example, this HTTP service has what we call use cases attached to it. For example, it may well have authentication, or credentials reset, or user registration. We threat model those use cases as well. Okay? Now what happens is that as the developers are selecting the components and they're selecting the use cases for them components, unbeknown to them, they're building the threat model at the same time. As they put the blocks on, the blocks of the threat model go on as well. Okay? And just as an example, OWASP ASVs has an authentication section, so you can do that. Okay? So what is threat modeling? Wonderfully, I only found out about this a week or so ago. Slack have released a tool called OSDL, and it is basically exactly what I'm saying to you. It's a web application, and it ties in with Jira and Trello. It's a self-service approach for developers, and it's passed over to them. First, they go through a quick risk analysis to see if they need the security team to be involved. If the answer to that is no, they then go on to select in a checklist the components for their architecture, and the relevant security requirements that have been written by the security team are brought in for them. So actually, I didn't know about this before. I only found out about this a couple of weeks ago. But there's no excuses. If you want to try this, check out Slack's OSDL. Okay, if we want to take this even further, and I think you probably do, don't you? We're going to get repetition. For example, a profile update or an authentication for a mobile device or a web device, they may have similarities and overlapping similarities. And it can be a pain for the security team to be continually updating multiple things that are basically repetition. So we lift a principle from the software development arena, dry. Don't repeat yourself. Okay? And this is what I'm going to call object-oriented threat modeling. Taking from the world of the object-oriented programming, that whole philosophy of inheritance, what we do is we take a generic service, and that could be as simple as a service that just listens on the internet for connections, nothing more. Okay? And then we threat model for that. We take a data store, a very generic data store, as basic as we can, and we threat model for that. Then we become more specific. A NoSQL database and a SQL database, we threat model for that. Now, a NoSQL database is a type of data store, and a data store is a type of generic service, okay? And will inherit the threats and countermeasures from those below it or higher up in the hierarchy. And one of the benefits of that, or just to show you that in JBoss Jaws, just very quickly, as you can see, user chooses JSON service, okay? Risk pattern JSON service is brought in. The rule engine fires. JSON service itself has a dependency. It knows that a JSON service is a HTTP service. The rule engine fires again. HTTP service has itself a dependency, which is a generic service. So you can see how this works. You know, how you code this, you could do this in Ruby or Python or whatever, how you code it, but that's just the principle of how you would code this. And the beauty of this is that it gives us the ability to overload methods, okay? So if we begin with this risk pattern down here, which is just for a client, we don't know which client, we have a threat, sensitive data is compromised if the client is compromised, and we've got two countermeasures. Do not store credentials on the client, and number two, encrypt data on the client if you must do so, right? Fair enough. As we move up, we can see that it's an iOS application that's being selected. And now we see that countermeasure 2 is encrypt by storing it in the key chain. So what we've done is we've become more specific for our developers here so that they have more granular information. It's not just high level, but they have more granular information as to how to actually implement this countermeasure. And so ultimately at the top, we have countermeasure 1, do not store credentials on the client, but countermeasure 2, encrypt by using the key chain or whatever else, has been overridden. So the original countermeasure 2 has been overridden and overloaded, okay? I bet I've lost everyone. The best way to do this is to, again, remove the complexity away from the developer or whoever is using this. We create a questionnaire, right? So what type of component are you building? A web service, username and password is the authentication. It goes through the rules engine, the JBoss D rules, and it calculates the risk patterns that are associated with that. So in exactly that, user chooses web service, okay? HTTP service, risk patterns chosen. User chooses username and password. Risk pattern single factor authentication is imported. And down here, because HTTP service and single factor authentication service are chosen, that's where the magic happens. It also imports a sensitive data transport risk pattern because it knows it's dealing with sensitive data. It also imports stateful session because it knows that this is an authentication issue. And we can even have specific risks and countermeasures associated with single-factor HTTP service. So we bundle all that together, and they get all of the risks and countermeasures that they need simply through selecting the architecture and its use cases. Okay? There are some disadvantages, of course. The first is checklist shortcut thinking. Well, that's a risk we're going to have to take. Garbage in, garbage out. It's as good as the selection that is made by the developer in terms of the components and the architecture, and also the quality of the security information that was put in the beginning. And notice we have no data flows or trust boundaries or diagrams, okay, architectural diagrams. So they are missing, right? But we have to make a trade-off if we're going to make this realistic for the environment that we're in now. And we must do threat modeling. We must do secure design. And you may fly with completely much better ideas than this, but I'm just trying to give you a flavor or an idea, a way of thinking about this so we can make this rapid and fast. And in the same time, we can pass over security knowledge to our peers, which is also very important now. Advantages, speed and scale, of course, consistency. The knowledge base will always remain in place, even if the security team leave. It's all documented. Self-service. The developers are now in a situation where they can make independent decisions. Then they understand why they're putting in security controls, and they can make decisions. They can make trade-offs. They can make risk decisions even. The knowledge base is there. And there's probably the most important thing to say is there's more time for the hard stuff. And what I mean is I don't want to walk out of here and people think I'm saying manual threat modeling is rubbish. It is not rubbish. If you've got the time and you've got only a few applications to do and you're in a slower environment, manual threat modeling is fantastic, okay? But this can be a great supplement to manual threat modeling. Say if you have a very high-risk application and you need to do some additional threat modeling on top. Getting a workable threat model that we can trust up and running fast is half the battle. We can then go on and manually threat model what's left if we have to. Okay? Jim Manico said recently, if you're threat modeling basic risks like XSS, HTTPS, SQL injection, a similar basic tech risk, you're doing it wrong. I agree. Okay? And my boss, Stephen DeVere, said, as a vendor in said industry, I heartily agree. We shouldn't be spending valuable brain power thinking about boring technical threats. That's what machines are for. We need human intelligence for business logic and independent stuff. Okay? I know I've flashed through this. It isn't a training course, but I was trying to get the gist of it out for you. If you do remember 3 things, and you probably won't, in 30 minutes, I'd ask you to remember threat modeling is awesome. It is. We can automate much of it, and we automate it based on architectural components-based threat modeling. Architectural components and use cases is the key, and we build them together. Okay. I don't know how long I took there. Did I rush through that really fast? I felt like I did. Anyway, is there any questions? Can I?
Hi. I've got a question. You're saying about the speed of this. Can you tell us more about threat modeling using code or threat modeling as code?
Absolutely. I thought about talking about threat modeling as code. Here's my proof. Okay, but the trouble is it's another talk. Okay, but I will say this: that the 2 most important open source threat modeling in the code is ThreatSpec. And that's Fraser Scott's baby. And Fraser Scott is in the audience. So, Fraser, would you mind coming up and telling us a little bit about ThreatSpec and answering this question on code? Might as well get the expert to do it, mightn't you? So, thank you, Fraser.
Thank you. Can anyone hear me? Yeah, cool. Yeah, so ThreatSpec was born out of the need to threat model an open source project. And how do you threat model something with people around the world in different time zones? How do you develop that? You work through code. You put it in Git. So the natural conclusion was, let's put the threat modeling in Git with the code. That's where we put our tests. So it was basically just an experiment. Actually, I spoke about it at the first DevSecCon, which was quite cool. And the idea was to just, let's do the threat model, or let's, as we're making security decisions, we'll put the thoughts that we're having about the mitigations and why we're making these decisions, put that in code, and then we can generate the threat model retrospectively, bring that into a group threat modeling session, and then we can kind of create those feedback loops that drive the overall quality of the threat model throughout the process. So it's kind of looking at half the solution, but the threat playbook is coming at it from a completely different approach, which is more how you feed it into the AppSec side of things as well, which is really, really cool. So if you're interested, come and chat to me. I'll be around today and tomorrow.
Okay, thank you. Did that help?
Are these tools available? Or
Yes, these are open source tools. You can find them online, ThreatSpec. And I think you're doing some kind of upgrade on ThreatSpec as well, aren't you? You were speaking about.
If you're interested, come on. Hello again. Yeah, so it started off as a very basic, regular expressions to just sort of map out mitigations, etc. Trying to evolve it into something a bit more descriptive, so you can describe architecture, and then you can sort of do the full loop from threat modeling in a group using ThreatDragon, another awesome project. You can use that for diagramming, get it in code through something like ThreatSpec, and then sort of continue the cycle that way. It'll be interesting to see how it can play with Threat Playbook as well. Yeah. I'm sure there's some interesting integration options.
Okay.
Any other questions? Okay, well, I think that's it then. Thank you very much.
Thank you very much.